Hello and welcome to Rygate Maths. My name's Simon and in this video we're going to be looking at quadratic graphs, how to sketch them, properties of them, and so on. Much like a lot of the quadratics content for the A-level, this should hopefully be a lot of revision from GCSE with maybe a little bit extra. So I've drawn a basic positive quadratic graph here. As we've kind of said in previous videos, the name of this curve is a parabola. Parabolas have an important feature that they are symmetrical about the vertex here. Okay, so this is the vertex as we've seen in previous videos, but this may also be called a turning point because the graph turns, a stationary point, which if you've seen differentiation before, you'll know what that means. If you haven't, it's something you'll do a little bit later on in the course. You may also see this referred to as a minimum point, because that's what it is. Here we have 2 points, in this case where the graph crosses the x-axis. These are the solutions to f of x equals 0, or the roots. Quadratics can have 2 roots, 2 real roots, 1 real root, or no real roots. We'll look at those in a later video. Here we have the y-intercept. And that's found when x equals 0. What is f of x? So f of 0 is what we are working out here. This line of symmetry is going to be x equals something, where the something is the x coordinate of the vertex. Whenever you're sketching curves, finding these points is a really useful strategy for kind of, I'm not sure what this graph looks like, I want to find some bits. So finding the y-intercept, finding the turning point, if there are any, finding solutions or the roots, if there is symmetry, finding a line of symmetry, all of those combined with the overall general shape, which in this case is a parabola, can really help quickly sketch graphs. These ideas we've done on a positive graph, but can also be adapted to this, with the only change being that this would be referred to as a maximum point rather than the minimum point we detailed here. Everything else would stay the same. Now, the important thing with quadratic graphs is the y-intercept will always exist. That will always be a thing, but there may not be any real roots. So you might not have points of intersection with the axis, in which case finding the turning point is going to be fundamental to being able to sketch the curve. So we've got an example here that we're going to work through together to sketch, ultimately, answer this question. Sketch the graph of y equals x squared minus 2x plus 3. So these strategies that we've split up into parts A and B here are, as I've said, really useful ways to think about the curve. Okay, so with solving x squared minus 2x minus 3 equals 0, this can easily be factorized. So we get our solutions as 3 and minus 1. Okay, nothing particularly outrageous there, just solving a quadratic equation. Be aware that if you're doing these questions in the exam, you might not get nice values here, you might get non-exact values, things like that. Still doing the same thing, just maybe completing the square or using the quadratic formula. Part B, express x squared minus 2x minus 3 in the form x minus p squared plus q. We can see here that just means complete the square. So writing this in completed square form, x minus 1 squared minus 1 squared minus 3, which is minus 4. And now we get on to the real point of this question. Sketch the graph of x squared, y equals x squared minus 2x minus 3. And it gives us a load of other instructions to do. You might not get told these instructions. So stating the coordinates of turning point, da 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 da. This is a very useful thing to just do out of habit. So we've already got quite a bit of information. From here, we know that this is where the graph crosses the x-axis. And we can use our completed square form to give us further information. So we can have the vertex is at 1 minus 4. You'll notice that these two values are the same distance away from this, from the x coordinate of the vertex. This is the first one is 2 above, the second is 2 below. This is again because of the symmetry of the curve. The only extra thing we need to do is find the y-intercept, which, given that we've got our function in this form already, is just here. So this is the y-intercept. With all of that information, we know that it's a positive quadratic, so it's a U shape. This is enough information to draw the graph. So what a lot of students will do will be diligently draw the axes, then plot the points, and then try and fit their curve through those points, which is fine. But what tends to happen is students will get graphs that kind of do this and are a little bit wobbly. This is not sufficient for the exam. A more advanced kind of strategy for sketching curves is, well, we know the shape's this. So let's just draw that. So we know this is the shape. So we know our roots are going to be at minus 1 and 3. So that's where our x-axis has to go. Whoops. Try again. Now, the thing with this is, if you draw it slightly off, and this is why you need to draw graphs in pencil, you just rub it out and redraw it. So minus 1, 3. So we know the line of symmetry is through the vertex, which is at 1 minus 4. And we know the y-intercept is minus 3. So that's going to give us a y-axis kind of looking like that with minus 3. Now mine's not particularly symmetrical, but it's symmetrical enough. Now, the examiners aren't expecting you to be able to draw these absolutely perfectly, but as long as it's symmetrical enough, you're good. Okay, so stating the coordinates of the turning point, we've done that. The points where the graph crosses the coordinate axes, we've got these 3 points here. We've got the 2 roots and the y-intercept, and the equation of the line of symmetry. So the line of symmetry has equation x equals 1, and if we wanted to draw it on the graph, we could. Whoops. And that's how you sketch curves. Even though we're doing this with quadratics, you can apply a lot of these rules to any sketching, whether it's a cubic graph, an exponential graph, anything like that. You can apply these rules. And thinking about these rules in terms of sketching rather than just working out a bunch of points and plotting them is going to be a much quicker and more appropriate method for sketching graphs. For our second example, we just have the instructions sketch the graph. Now, in the actual A-level exam, you'll likely have a little bit more structure to this, like we've just gone through. However, you still need to be able to cope with just this instruction, because it might come up. So following the steps that we did in the previous example, have a go sketching this graph. So pause the video, have a go at this example, unpause, and we'll go through it. So going through this example, first off, the major difference is that we have a minus x squared, which tells us it's this n parabolic shape. Now you'll notice, unlike the example we went through together, I did the whole thing by completing the square. The reason I did that is because finding the vertex, and hence the line of symmetry, and the maximum value, all comes from completing the square, and you can find the roots from the completed square form. So I just did it all using that. If you didn't and you factorised it instead, totally fine. When you are completing the square, though, do be careful with the fact that it's minus x squared. If you're going back and just completing the square with the x squared minus 2x minus 8, you'll get the vertex in the wrong place. You'll get it as 1 minus 9, which then contradicts the idea that the y-intercept is 8, because we've got this upside down parabola. So we can see here we've got our roots at 4 and minus 2, our y-intercept at 8, our vertex at 1, 9, and if we needed to, our line of symmetry would be x equals 1. Not all graphs have a line of symmetry. Quadratics do, which is great, but cubics that you'll look at in later weeks, in later videos, aren't symmetrical, so we can't, or don't have reflectional symmetry. So we can't really do that, but you might be able to think about other bits of information. Other more advanced things you can look at, and more generally with graphs, are there asymptotes? Quadratics don't have asymptotes. What happens as x gets really, really big? What happens as x gets really, really big, but in a negative direction? If you've got asymptotes, what happens as x gets close to the asymptote? These are all other things that you can think about when you're sketching curves. But that's a much more advanced thing. These you don't need to worry about for quadratic curves. These are more useful when you're thinking about reciprocal curves, exponential curves, logarithmic curves, things like that. All of these that you'll look at in later topics. But thank you very much for watching.